the quadratic formula, used to find the zeros when all else fails. To find this and to find this. So the quadratic formula will allow us to find the solutions, also called the zeros, or the x-intercepts, to a quadratic equation when we cannot factor it. So we've been solving all these things by factoring, and we've been dealing with trinomials that we can factor. And the reality is, if we come across something we can't, we've just said not possible. Now it's true we can't factor it, but it doesn't mean that we don't want to deal with it. What happens when we can't factor it? All it means is that the zeros, or the points that hit the x-axis, aren't integers. They're landing in between these perfect integer values. So there still are zeros, they still exist, we just can't get them with our little tricks of adding to the middle and multiplying to the last. So to get around that, we have a formula that gives it to us. So this is what it looks like. I know it looks a little intimidating initially, but it's actually not too bad. So here's our general quadratic in analytic form. So ax squared plus bx plus c. Now the quadratic formula is x equals, so it's going to tell us the solution, x. It's equal to negative b. So here's our b value. This is a number, don't forget. So a is a number, b is a number, c is a number. So we're just taking the three numbers out of the analytic version and plugging the numbers into this formula in these certain spots. So we start with negative b. Now this symbol is a little bit strange. This is plus or minus. So we say plus or minus. These are two operations stacked on top of each other. It just makes it a little more efficient to write the expression. So we have the plus or minus. So we're going to have this negative b plus this radical sign, or negative b minus this radical sign. And we say, well, hang on now, if I do plus and minus, isn't that going to give us two answers? And of course that is correct, because the solution to a quadratic always has two. There's one here and there's one here. There has to be two values. So this plus or minus is telling us to actually do two things. It's saying execute the formula with a plus and ignore the minus. And then it says do it again, but execute the formula with the minus and ignore the plus. So it's like having basically two equations kind of stacked on top of each other. So what it means is, just to go over it once, the whole thing once, it's negative b, so whatever this value is, plus or minus the square root b squared minus 4ac, so a times c, all over 2 times a. So let's try an example here. We're going to solve this quadratic. We know we can factor this, so we're just quickly going to factor it, find two numbers, add to 5, multiply to 6, two numbers are 2 and 3. I plug them in, I solve, and my answer would be x equals negative 2, x equals negative 3. So we can solve this one by factoring. But suppose we don't want to factor it. Suppose we want to use the quadratic formula. Okay, it's just to remind ourselves, the answer is negative 2, negative 3. So use the formula. So identify a. Now, if there's no number out front for the a, I'm going to call it 1. B is the second value, 5. And c is the last value, 6. And there's the 1 sitting out front. So the 1 is the a, b is 5, and the c is 6. Now here's my general quadratic equation. Now I just plug everything in. So negative b, so here's my b, so negative 5 is to go here, plus or minus the square root b squared, my 5, so 5 squared, minus 4ac. Well, a is 1, and c is 6. Just plugs in there and there. All over 2a. 2a. A is 1, 2a. So really it's kind of complicated, but it's really just substitution that we're doing. And once it's in, we just begin to operate. So I have negative 5 here. I square the 5 squared, becomes 25. 4 times 1 times 6 is the 24. I do the 25 take away 24. 25 take away 24 is 1. That leaves me the 1 here. I know the square root of 1 is 1, so that brings me to here. And here's where I break into my two parts. My plus minus, I now break it up. So I have negative 5 plus 1 over 2, and negative 5 minus 1 over 2. So there's the plus, there's the minus. I just pull this symbol apart, and I deal with the plus and I deal with the minus. So I know negative 5 plus 1 is negative 4 over 2, and negative 5 minus 1 is negative 6 over 2. Negative 4 over 2 is negative 2, and negative 6 over 2 is negative 3. And there are my two answers. Same thing. So the quadratic formula gives us the same answer. So now you're saying, well, why would I use the quadratic formula on something I can factor? And of course the answer is you wouldn't. So we're always going to try to factor first. But if we come across an expression we can factor, we don't want to give up, we're going to kick over to the quadratic formula. We get the same answers. So we can try this one. I'm going to common factor first, divide out the 2, and then I'm just going to, again, I can factor this just to find my answer quickly. So I know I'm going to have these two things using my 0 property, negative 5, x minus 5, x plus 3 is 0. And that allows me to get my answer as 5 and negative 3. If I use a quadratic formula, so my a is 2, b is negative 4, and c is negative 30. Here's my formula, negative b plus or minus root b squared minus 4ac over 2a. So my negative b, there's my 4. Now this is interesting because it's negative b and b is already negative. So if I have negative b and I plug in a negative 4, that's going to become obviously positive 4 because a negative times a negative is a positive. So that's why this is positive 4 sitting down here. Plus or minus b squared minus 4ac, a is 2, c is negative 30, all over 2a. And then really from here it's mechanics all the way down. And you're going to do these steps quicker, of course, eventually. I add the two terms under the root. I take the root, which ends up being 16. And now I have my two cases, 4 plus 16 and 4 minus 16. And when I work them out, I get the same answers, 5 and negative 3. Now, another quick shortcut here. Since we have now defined a, b, and c, there's actually a formula that will help us find the vertex. So remember, really the quadratic formula is giving us the zeros. It's giving us this value and this value. Now, suppose you want to actually find the vertex. Well, this little quick formula here will give us the x value of the vertex. So even if we don't go ahead and find the zeros, we can cut right to the vertex with this. Now, one thing we need to be aware of the quadratic formula is this radical sign, this root sign. There's some properties with the roots we need to be aware of. Okay? That root kind of controls the type of answers that we get. So we know with quadratics, with the type of solutions, there's actually 3 different cases we need to take a look at. There's this first case here, where we have these two values, which we find with factoring. We've seen before with factoring. There's this case here, where we have one value. We've seen before with factoring. This case over here on the right-hand side, we haven't really dealt with this, because factoring hasn't allowed us to get into this, but the quadratic formula will. So we just need to be aware of this now, because really the quadratic formula will work on anything. So now we have to sort of realize and sort of deal with all the possible cases. So the first one, when we have these two roots, okay, we call them two, they're different, and they're real roots. And that's the case where the square root part of the quadratic, b squared minus 4ac, is bigger than 0. It means this is a positive value. So this could be a number like 10 or whatever, 12, 15, 0.3, whatever positive value, it has to be positive. And we can find the square root of a positive number, whatever it is, and we take our two, we break it apart, we do our plus and minus, and we get our two answers. Okay. The second case is where this root part, b squared minus 4ac, equals 0, which means it kind of actually drops off from our expression. It means we add 0 and we subtract 0, which really doesn't make a difference on our answers. So we actually get two equal real roots. There's two roots, but it's actually the same number because we're adding 0. So we classify that as two equal real roots. Now the last one, this part is new, is a little bit tricky, is where we actually have what we say no real roots. And that means that the square root part of the quadratic is less than 0. It means it's a negative. It means we're being asked to find the square root of a negative number. And we can't do that. It breaks down in our calculations. The square root of a negative number does not exist. So the quadratic formula, it kind of falls apart if we have a negative root. It's not wrong, it's not bad, it's just that it won't work on a negative. And what that means is that there are no real roots. It means the parabola, it never strikes the x-axis anywhere. It never hits it. It's floating up in space here. It's floating up around the Cartesian plane. Or it could be below it. It could be a negative, it could be upside down, it could be below it. It's not wrong, it's not bad, it's not incorrect. It's just because it fails to come down and strike the x-axis, the quadratic equation can't find it. It can't grab it. It can't get it. We recognize that with this negative root. Now, for interest's sake, just the last slide here, if you have the quadratic in analytic form, and if you use that process complete the square, that actually creates the quadratic formula. That's where it comes from. It comes from completing the square on an expression in analytic form. And this little animation here kind of goes through it back and forth. Don't worry, I'm never going to ask you to do this. I just thought it was kind of interesting to see where it comes from. That's it.